we've been working on these proof type problems lately, and I have another one for you. I just want you to feel comfortable with these problems here. So here's the deal. I want you to compare cosine of x with 1 minus x squared over 2 on this interval where x is between 0 and pi over 2. So why don't you pause the video and try to establish a proof for this to figure out what the inequality is. All right. Assuming that you've given it a go, again, I'm going to use my favorite method here. That is going to be method 1 that we talked about in last video. So we're going to say start. We're going to say start. Start, and we're going to name a function. This will be g of x, and g of x has to contain all of this information here. So we're going to say it's cosine of x minus this whole thing, 1 minus x squared over 2, that whole quantity. So we have cosine of x minus, and then 1 minus this whole quantity, 1 minus x squared over 2. And again, we're looking at this interval here, where x is between 0 and pi over 2. All right. And we should first ask, okay, is g of x continuous, differentiable on this interval? Can we talk about it? Can we take its derivative? Yes, we can. It's continuous and differentiable for this interval. And let's just look at g of 0 first. Let's find a base point to look at, so we can look at g of 0 first. Cosine of 0 is 1 minus, and then we have 1 minus 0. So this whole thing is 0. G of 0 is 0. And now we want to take the derivative. So g prime of x is going to be derivative of cosine of x is negative sine of x. And then we have and then derivative of... So we actually don't have minus. Let's hold that off. Derivative of negative 1 is 0. And then the derivative of positive x squared over 2 is going to be, you bring down the 2, and then the 2's cancel, so you just have x. So you just have x. So this is plus x. All right. So now we need to decide, is our derivative positive, negative, equal to 0 on this interval? We have to figure that out. And if you can remember, in the last video, we actually did this. We proved that sine of x, maybe I can put in a different color. We proved in the last video that sine of x is actually less than x on this interval. So if that's the case, and we proved that in the last video, maybe go check it out if you didn't see that. If that's the case, well, then that means that our derivative, because sine of x is less than x, that our derivative is actually going to be positive. It's going to be positive if sine of x is less than x for our interval here. So if our derivative is positive, again, as a consequence of the mean value theorem, that means that our function is increasing on this interval here. And therefore, we're able to make a comparison between g of x and g of 0. And we're able to say that g of x is greater than g of 0. And then all we need to do is fill back in some information. So we said that g of x is cosine of x minus 1 minus x squared over 2, that whole quantity. And we said that this is greater than g of 0, which we found to be 0. And then adding this guy back over, we just have that cosine of x is greater than 1 minus x squared over 2 for our interval. So we are done. And just before we go here, again, maybe we can mention that 1 minus x squared over 2 is actually the quadratic approximation for cosine of x at x is equal to 0. So that's cool. But then also I want to show you this graph. Show you this graphically, what's going on here. So cosine of x is in blue, and then 1 minus x squared over 2 is in pink. So you can see that cosine of x looks to be greater than 1 minus x squared over 2, and we proved that that is the case. We could throw that here. And we're done.